Hi students, in this video we are going to discuss about electrolysis, the kind of conduction that takes place in compounds as well as in metals, and what is the difference between these conductions and what do you mean by electrolysis, what is this process. We are going to see various aspects of this in this video, so keep watching. Conduction of electricity is of two types. We have to first understand the difference in the conduction of electricity. Now the conduction of electricity is through the metals as well as the chemical compounds. There is a lot of difference between them. So we will discuss these things. So in this video. So the metal wires like copper wire, example a copper wire. How the electricity passes through copper wire and how it passes through other substances like chemical compounds like aqueous solution of sodium chloride. So what is the difference in the way of conduction in these two substances and what is responsible for this conduction? So this is what we are going to discuss first before we understand what is electrolysis. So let us see the conduction of electricity is named, one is named as electronic conduction or otherwise metallic conduction. The second one is Ionic conduction or electrolytic conduction. The name itself tells electronic conduction means electrons are involved and it happens in metals. Here ions are involved and it happens in chemical substances, electrolytic solutions, right? Now, what is the particle or what is the key factor that is responsible for the conduction? Under electronic conduction or metallic conduction, free electrons are responsible. We know metals have free electrons. Their valence shell is ready to donate electrons, free electrons. Same way, free mobile ions are required for this type of conduction, that is in the ionic conduction. The particle must split into free ions, then it will happen. So that is in a chemical compound. Example, sodium chloride splitting into Na plus and Cl minus in aqueous solution. So this is required. Whereas in the metallic conduction, electrons are required, right? Now, the next thing is electronic conduction takes place in metals, as I already said, and this ionic conduction takes place in chemical compounds or electrolytes. Now, the other difference is under electronic conduction, that is current passing through a copper wire, the matter is not transferred. Example, you put a copper wire through a pipe or a conduit in your house and wiring is done and you switch on the light, you turn it off and keep doing it, and for years it is there and the copper wire does not undergo any change, it remains as it is. Whereas in a chemical substance like sodium chloride, aqueous solution of sodium chloride, here the matter gets transferred. Sodium ions migrate to the cathode, chloride ions migrate to the anode, and products are all formed there. So there is a chemical change happening there. So here we see electronic conduction, no chemical reaction, whereas in the ionic conduction, a chemical reaction takes place or it is involved. And the other thing is we can say no new substance is produced in current conduction through a metal, whereas new substances are produced, they are formed as products during conduction through a chemical compound. And then we also have, they takes place, the metallic conduction, usually a copper wire, is a solid state, it is in solid state. Whereas the chemical compounds, the conduction takes place in molten state or aqueous state. Under the properties of ionic compounds, we have discussed this in the previous videos. So that molten state and aqueous state, they produce free mobile ions, and solid state they do not produce. That's what we have seen. So this is the major difference between the two types of conduction, electronic conduction and ionic conduction. And examples we can take for electronic conduction, it is conduction through copper wire, and for the ionic conduction, a chemical cell like a dry cell battery that you have your home, you must be using in your TV remotes and other things. The number of cells are available, so they are all ionic conducting substance. Ionic conduction takes place there. Now the next is substances are classified, electrolytes and non-electrolytes. What are electrolytes and non-electrolyte? Chemical substances are classified as electrolytes and non-electrolytes on the basis of their electrical conductivity. Now understand, here we are talking about compounds. We are not talking about metals here. Under electrolytes and non-electrolytes, we are talking about chemical compounds. Okay. Electrolytes are substances which conduct electricity in the molten or aqueous state. Please emphasize the state. Electrolytes means we are talking about the substance in the molten state or aqueous state. What is molten state? We have already discussed, and once again we will see here molten state means substance the substance is as solid under ordinary conditions or ordinary temperatures. Okay. It is a solid at ordinary temperatures. It is heated. Now it is heated to high temperatures. Heated to high temperatures to melt. So once it is undergone melting, now we say it is molten state, and it is not at ordinary temperature. Please remember, molten state is not at ordinary temperature, it is at high temperatures. Now when you are converting something to a liquid at high temperatures, it is clear that the substance at ordinary temperature is not a liquid, it is a solid. Okay. Then aqueous state is substance dissolved in water. Substance dissolved in water. We have discussed about both these things under properties of ionic compounds. You can see that video again. So there we have discussed when aqueous substance, ionic compounds dissolving in water and splitting into ions. So here again free ions are present, free mobile ions. Free mobile ions are present. And in the molten state also free mobile ions present. Okay. So this is something to understand. Okay. So substances are classified as electrolytes and non-electrolytes. Electrolytes are substances which conduct electricity in the molten or aqueous state. Now what are non-electrolytes? Non-electrolytes are substances which do not conduct electricity in the molten or aqueous state. Let us compare their properties. Now here we see electrolytes, substances which allow electric current to pass through them in molten or aqueous state. Okay. And they split into free mobile ions in molten or aqueous state. This is important, why that happens in the molten or aqueous state. And they consist of free mobile ions and are responsible for conduction. The free mobile ions, these are the particles responsible for conduction. And example, we have molten sodium chloride. Sodium chloride can be heated to melting, NaCl, or it can be dissolved in water, aqueous NaCl. So when you heat it to melting, what happens? NaCl changes to Na plus and Cl minus. Okay. And when you dissolve it in water, NaCl plus water, you dissolve in water, what happens? It splits to Na plus and Cl minus, and also water producing H plus and OH minus ions. So all these ions are present there, right? So they conduct. The free mobile ions are responsible for conduction either in molten state or in aqueous state, right? Then let us talk about non-electrolytes. These are substances which do not allow electric current to pass through them in the molten or aqueous state. Again we are talking in the molten or aqueous state. Please remember that molten state or aqueous state. In this state it is not conducting. We are not bothered whether if it is conducting in solid state or not. That we are not discussing here. We are seeing that the substance is not conducting in the molten state and aqueous state. Then we put it as non-electrolyte. Then the reason it does not split, these substances do not split into ions in any state. Okay, so free mobile ions are not there. They consist of unionized molecules and hence cannot conduct. No ions present. Ions absent. You should note that free mobile ions are not there, they are absent. Only unionized molecules are there. And example, we have carbon tetrachloride CCl4, carbon disulfide CS2. You do anything, they will not split into ions. Okay, so they are non-electrolytes. So I think it is clear what are electrolytes, what are non-electrolytes, right? The next thing we have to discuss is there are two types of electrolytes. Electrolytes are substances which conduct electricity in the molten or aqueous state, and there are two types. One is a strong electrolyte, the other is a weak electrolyte. Now what is a strong electrolyte? A strong electrolyte dissociate or split into ions almost completely in molten or aqueous state. Again, emphasize on molten or aqueous state. It splits almost, means all the molecule will split into ions. They have high concentration of free mobile ions. Free mobile ions, high concentration. Suppose there are 100 molecules, almost 99 of them split into ions. Okay, so there is high concentration of mobile ions. And because there is large amount of ions, large amount of electricity is passed through it. It can conduct large amount of current because there is large number of mobile ions. Example, we have dilute sulfuric acid, H2SO4, splitting into hydrogen ions and sulfate ions. So all the molecules of sulfuric acid will split into ions. There is no unionized molecule here. So there is high concentration of mobile ions. So it conducts large amount of electricity. Right? Now let's talk about weak electrolytes. They dissociate partially in the molten or aqueous state. As I said, if there are 100 molecules, what happens is only about 40 molecules split into ions. The remaining molecules remain as it is. They don't split into ions. So they consist of low concentration of free mobile ions. Free mobile ions are there. At the same time, there is also unionized molecule, and the amount of ions is very low, and therefore they allow small amount of electric current to pass through. Now because of this, the current passed is low because small amount of free mobile ions. Example, acetic acid, it splits into ions CH3 COO minus acetate ion and hydrogen ion. See, it is splitting, but the thing is all molecules do not split. Only some molecules are splitting. The remaining molecules stay as unionized molecules. So the amount of mobile ions available is less. So current passed is less. So that is about weak electrolyte. The next thing is, let us compare all the three. We have seen non-electrolyte already, and electrolytes are put into strong, weak and non-electrolytes. A comparison between the three. Now strong electrolytes undergo complete dissociation in the molten or aqueous state. Now weak electrolyte undergo partial dissociation in the molten or aqueous state. And non-electrolyte, what happens? They undergo no dissociation in the molten or aqueous state. I think you are understanding this. And the second thing is, the strong electrolyte consists of only ions in the molten or aqueous state. Because all molecules are dissociating, only ions are present. And weak electrolytes consists of ions as well as molecules in the molten or aqueous state. Why? Because some molecules split into ions while other molecules do not split. What about non-electrolyte? They consist of only molecules. No splitting, no ionization, no ions formed. Right? And the third thing is, strong electrolytes, they conduct large amount of electricity, while weak electrolyte conducts small amount of electricity, and non-electrolyte conduct no electricity. Nothing is conducted. Okay, I think you understood this comparison table. So you should compare substances in this manner. The next thing is examples of strong electrolytes. What are the examples of strong electrolyte? Example, strong acid, hydrochloric acid HCl, nitric acid HNO3, H2SO4, sulfuric acid. This is hydrochloric acid. You are familiar with hydrochloric acid. It's a strong acid and it's also strong electrolyte. Nitric acid is a strong acid and also strong electrolyte. This is sulfuric acid, which is also a strong acid and strong electrolyte. Okay. Now same way, these are all examples of strong electrolytes. Same way, strong alkalis. Example, sodium hydroxide, NaOH. Sodium hydroxide. It splits into ions, almost complete dissociation. So it's a strong electrolyte, strong alkali as well as strong electrolyte. Same way, potassium hydroxide, KOH. Potassium hydroxide. Okay, these are strong electrolytes. Then the salts formed by strong acids. Example, hydrochloric acid produces salts called chlorides. Okay, chlorides, that is sodium chloride, potassium chloride, ammonium chloride, and so many chlorides produced. These chlorides are strong electrolytes, the salts of these strong acids. Now one thing to notice, in the molten or aqueous state, this is important, in the molten or aqueous state. If you don't mention the state, it would be wrong, okay, because in solid state they do not conduct, right? And same way, nitric acid gives salts called nitrates. So the salts, whichever salt is a nitrate, nitrates are strong electrolytes in the molten or aqueous state. Usually salts are solids. So you must mention molten or aqueous state. If you don't mention state, the original state, the natural state of the substance is considered. Okay. Example, if you say sodium chloride usually is a solid. So everybody understand you are talking about solid NaCl. Now if you mention molten NaCl, then people think, okay, this is molten, means it has split into ion. Same way, if you say aqueous NaCl, then we say, okay, it has dissolved in water, therefore it has ions. So state is important, always you mention the state. Now H2SO4, sulfuric acid, gives salts called sulfates. So these will also in the molten state will split into ions, therefore they are strong electrolytes. Then salts of strong alkalis NaOH, The salts of NaOH are called sodium salts. All the sodium salts. Example, sodium chloride, sodium nitrate, sodium sulfate, sodium carbonate, and even other salts of sodium. Sodium salts are strong in the molten or aqueous state. I always mention this, in the molten or aqueous state. Now, you must be wondering why we didn't say molten or aqueous in the case of the strong acids, because acids, they are always liquids, they are aqueous forms. HCl, HNO3, H2O, they are always in the aqueous form. So where there, even if you don't mention, it will be correct. Whereas in the case of alkalis, here again you have to say in the molten or aqueous state. Why? Because molten or aqueous state. In this case also you will mention. Why? Because NaOH and KOH under ordinary condition, they are solids. They have to be dissolved in water to form sodium hydroxide solution, potassium hydroxide solution, right? So NaOH, salts of sodium. Now KOH, potassium hydroxide, is a strong electrolyte. Its salts also, that is potassium salts, potassium carbonate, potassium bicarbonate, etc. Potassium salts. Okay, so these are all strong electrolytes, examples of strong. I think you understood. Strong acids are strong electrolytes. Strong alkalis in the molten or aqueous state are strong electrolytes. The salt of strong acids, that is chlorides, nitrates, and sulfate, in the molten or aqueous state are strong electrolytes. Same way, salts of strong alkalis, NaOH and KOH, in the molten or aqueous state, sodium salts and potassium salts. Now the next is example for non-electrolyte. Non-electrolytes are non-polar covalent compounds are non-electrolytes. What are the examples? We have carbon tetrachloride, okay, CCl4, we have carbon disulfide. These are the most common examples for you. Carbon disulfide, okay, CS2, and we can also have other compounds like benzene, toluene, xylene, etc. Anyway, these two are the main examples for you. Okay, so these are all examples of non-polar covalent compounds. Since they do not split into ions, they are non-electrolytes. Okay, now second example for non-electrolyte is any substance in solid state is a non-electrolyte. Example, solid NaCl. We have seen NaCl in solid state has no free mobile ions. It has ions, but they are not mobile, so does not conduct. It's a non-electrolyte. Okay, and the same way, this the aqueous form and molten form, they are strong electrolytes, whereas in the solid state it is a non-electrolyte. Understand, any substance in solid state is a non-electrolyte. Example, copper wire. Copper wire does not have free mobile ions in it. It has free electrons. It may conduct electricity, but it has no free mobile ions. It will not split into ions. So ionic conduction does not take place. Therefore, it is a non-electrolyte. Please understand these things. Okay. So that's example of non-electrolyte. Now, what is the example for a weak electrolyte? It's very easy to remember weak electrolyte, because if a substance is neither a strong electrolyte nor a non-electrolyte, then it is a weak electrolyte. If it does not come under these two categories, that is a weak electrolyte. That is easy to identify a substance. So when you look at a substance, always think whether it is a strong strong electrolyte or weak electrolyte or non-electrolyte. So that way we can see. Now I have some examples for you. We have some dilute sulfuric acid. We have seen dilute sulfuric acid. It splits into ions completely, so it is a strong electrolyte. Okay. Solid NaCl. It is a non-electrolyte. Just now only we discussed. Why? Because in solid state the ions are not free and mobile. Okay. It's a non-electrolyte. KOH. Nothing is mentioned. Potassium hydroxide under ordinary conditions is a solid. So it is a non-electrolyte. Okay, see, think very carefully. Do not just see by the name only. Always consider the state. Now, molten KOH, it is in the molten state, it is a strong electrolyte. See the difference, no? Strong electrolyte. And acetic acid. Acetic acid is a weak electrolyte. We have already taken it. Weak electrolyte. Because it is not coming under the category of strong electrolyte or non-electrolyte. Aqueous NaCl, sodium chloride in aqueous state, it's a strong electrolyte. It dissolves in water, splits into ions. Aqueous KOH is a strong electrolyte. We have just seen that. Then cane sugar is the sugar that we have at home, that is C12H22O11, the sugar that we eat. edible sugar, okay. It does not split into ions. It's a non-polar covalent compound. It's a non-electrolyte. Non-electrolyte, okay. And same way, you can have more examples. Now, glucose, aqueous solution, glucose solution is also non-electrolyte because it does not split into ions. Sulfur is a solid. It's an element, not a compound, and it's a solid. Sulfur is a solid at ordinary temperature, non-electrolyte. Aqueous ammonia is a weak electrolyte. Aqueous ammonia solution, that is ammonium hydroxide, is a weak electrolyte. Magnesium chloride is a chloride. It's a salt of hydrochloric acid, and no state is mentioned, so it is a solid at ordinary temperature, so it is a non-electrolyte. Magnesium chloride is a solid. Now, dilute hydrochloric acid is a strong electrolyte. The acid it is. Now, the magnesium chloride, remember, even though it's a chloride salt, because no state is there, it is a solid. Because normal ordinary condition, it's a solid. Because it is solid, it is non-electrolyte. Yes, sodium hydroxide, again state is not mentioned, ordinary condition it is a solid, so it is a non-electrolyte. Copper sulfate, no state mentioned, ordinary conditions it is a solid, so it is non-electrolyte. Nitric acid, whether it is dilute, concentrate, it is always aqueous, so it is a strong electrolyte. It's a strong acid, strong electrolyte. Carbon tetrachloride, non-polar covalent compound, non-electrolyte. Carbon disulfide, non-polar covalent compound, it is a non-electrolyte. Copper metal, it's a solid state, metal wire is a non-electrolyte. Aqueous ammonium chloride, ammonium chloride is a solid, but it is aqueous, dissolved in water, it's a chloride salt, it is a strong electrolyte. Then aqueous sodium carbonate, sodium salt it is, and aqueous form, so it is a strong electrolyte. Molten sodium chloride, molten form, it is a strong electrolyte, and also it is an ionic compound, sodium chloride. Aqueous copper sulfate, again strong electrolyte because it is in the aqueous form. Lime water is calcium hydroxide. It is a weak alkali, dissociates partially, it is a weak electrolyte. Okay. So, I think you understood by this discussion what are the examples, what are strong electrolytes, weak electrolytes and non-electrolytes. Now, two questions I have for you. Just think about this question. Give reason. Solid sodium chloride does not conduct electricity, but its aqueous solution does. Why? Reason is solid NaCl, the other one is aqueous NaCl. Okay. And they are saying, the question says that solid NaCl does not conduct. Why? Here solid state, absence of free mobile ions. We have already discussed this. Yes. Therefore, no conduction. Got it? And aqueous NaCl, presence of mobile ions. Okay. Presence of free mobile ions. Hence, conducts. Okay. Is clear? Now, another question we have is, solid magnesium chloride does not conduct electricity, but it conducts in the molten state. Solid magnesium chloride, solid MgCl2. Okay. Solid state means no free mobile ions. Ions are there, but not free and mobile. No free mobile ions. So, no conduction. Now, the other thing is molten NaCl. Sorry, molten MgCl2. The question says MgCl2, magnesium chloride. Molten state, yes, ions have become free. That is presence of free mobile ions. Therefore, conducts. So, you understood, if a substance conducts, it is due to presence of free mobile ions. If it does not conduct, due to absence of free mobile ions. High concentration of mobile ions, large amount of electricity conducted. Low concentration of mobile ions, small amount of electricity conducted. And no mobile ions, no electricity conducted. So, students, I think you understood this well, and please go through it again and try to answer these questions yourself, and try to write some names of compounds and classify them. If you have questions, please write it as comments and subscribe the channel and like it. Thank you.